Hi everyone, the fundamentals of logic. This is the second video on the fundamentals of logic. In the first video, we saw the definition and applications of the fundamentals of logic and propositional of logic, and we saw the basic concepts in the logic, and we also saw the logical connectives and the truth table also. Still you didn't check means please go and check that one, and this is the continuation of that video. And this video will see the converse and inverse and contrapositive, and we will also saw the tautology and contradiction and logical equivalence. Okay. First, we'll see the converse and inverse of the contradiction and the contrapositive. What is the meaning of converse and inverse and contrapositive? In a fundamental logic, these terms are the transformations of the conditional if-then statement. They help in analyzing and reasoning about the logical relationships between the propositions here. They are the analyzing and reasoning about the logical relationships between the propositions. They will tell about the relationship between the propositions. What is the meaning? First, we'll see what is the meaning of conditional statement. We already saw that one. That is conditional statement means we written as a if P then Q. This is the symbol for the conditional statement here, meaning if P then Q. It is a P is here hypothesis, and it is also called as the antecedent, and the Q is called as the conclusion, consequent. Okay. The transformation of the conditional statement. The first one is here converse. What is the converse means? The converse of if P then Q is if Q then P. It is a symbol for the conditional statement. Okay, it is a symbol for the conditional statement. What is the inverse here? The inverse of if P then Q is here if negation P then negation Q. Negation P, conditional statement, negation Q. It is called as the inverse. And what is the contrapositive means? The contrapositive of if P then Q is here if negation of Q then negation of P. We will see this converse and inverse contrapositive using the example here. Using the example we will see here so that it will more clear. See here the statement types here. This is the conditional, because the conditional statement only we are transforming into converse, inverse and the contrapositive. So conditional statement if P then Q here, their converse changes it as the if Q then P. It is the changes of Q. If Q then P means it's the converse. If negation of P then negation of Q, it is the inverse. If negation of Q then negation of P, it is a contrapositive. How to read means here we took here two propositions here. The first one here, it rains, and the second one is here. The second proposition is here, the ground is wet. Okay. How to read this one? If it rains, then the ground is wet. This is the conditional proposition here. Next one is the converse. Converse, how to write means first we will write the Q first. Then if the ground is wet, then it rains. Here if and then. Okay. Next is the inverse, the negation of P. Then if negation of P, then Q. So if it does not, we have to use the negation here. If it does not rain, then the ground is not wet. We have to use here both the P and Q. We have to use the negation here. If it does not rain, then the ground is not wet. Here in the contrapositive, first we have to write here if negation Q, then negation P. Negation Q means if the ground is not wet. This is also negation. If the ground is not wet, then it did not rain. So it is did not rain. Okay, this is the example for the converse, inverse and contrapositive. Hope all of you understood this one. Okay, next we will move to the next. What is the meaning of tautology and contradiction? What is the meaning of tautology means? It is a logical statement or a proposition that is always true regardless the truth values of its component propositions. It means that it contains only one or t in the final column of the truth table. In the final column of the truth table, we will get the t only, the t only. Otherwise, we can, in the numerical means, you can write it as 1. Okay. This is called as the tautology. Next, contradiction. Contradiction means it is a reverse of tautology. In the final column, if we get the false, F or 0, numerical representation is 0, then it is called as the contradiction. A contradiction is a logical statement or proposition that is always false, regardless of the truth values. Whatever the truth value, it is not depend that one. It component proposition, it means that contains 0 or false in the final column of the truth table. Here the tautology is always true here, and the contradiction, it is always false, and the truth value is here. You can t, otherwise in a numerical means you can denote with the 1, F or 0. For example, here P, it is a P or negation P, always true this one. P and negation P, it is always false. Okay, you can see you can put the you can write it in a table. truth table, you will get always this is the true, and this is the final column, it is always you will get the false. So this is the example for the tautology. This one, it is always true. So this is the P and negation of P. This is always false. So it is the example for the contradiction. The next one is here logical equivalence. Logical equivalence. What is the meaning of logical equivalence? Means the two propositions P and Q are said to be logically equivalent if they have the exactly the same truth values. If you got the in the truth table, if you got the both the column, we will get the same truth values under all circumstances of the biconditional is a tautology. It is called as a tautology. It is denoted by which symbol? Means this symbol, otherwise the 3 bars. In the equal to sign, we will write the 2 bars. Na? It is a three horizontal bars. In the P, it is the equivalence. This is the symbol is equivalence. P equivalence to Q. If you write P equivalence Q and say that is P and Q are logically equivalent, it is called as they are called as logically equivalent. Okay. Logical identities, laws of logic. This is the laws of logic here. We already saw the identities law. These all laws are we will saw in the set theory also. The same will applicable here also. Which laws are satisfied here? We'll check here. The logical identities of laws of logic here. The first one is here identity law. Identity law means P and T. P is a proposition here. T is a that is a truth value. It is a true here. P and true. It is the P. It is a P only. P or false. It is also P. It is a identity law. Domination law. P or T. It is equivalent to T. P and F. P is the proposition here. F is the truth value. F. It is the equivalent to F. Law of double negation. Double negation means it is a negation of negation P. It is equivalent to P only. Idempotent law. Idempotent law means it is P and P. It is equivalent to P. P or P equivalent to P only. Commutative law. P and Q equivalent to Q and P. And another one is here P or Q equivalent to Q or P. Both are holds good here. Associative law also holds good here. P and Q and R. It is equivalent to P and bracket Q and R. And for R also P or Q or R equivalent to P or bracket Q or R. Okay, this is so commutative law also holds good, associative law also holds good. It is both are equivalent, and distributive law also holds good. It is also equivalent. P and bracket Q or R equivalent to P and Q or P and R. And another one distributive law is here P or bracket Q and R here equivalent to P or Q and P or Q. De Morgan's law also holds good here. Negation of P and Q, it is equivalent to negation of P and changes to here or. Negation of Q. Negation of P or Q equals to negation of P or changes to and negation of Q. Absorption law. That is P or P and Q is equivalent to P. P and P or Q, it is equivalent to P. Next one is the negation law. Otherwise, you can also call it as the inverse, otherwise the complement. Okay. P or negation P, it is equivalent to true. This is the truth value. It is a true. And P and negation of P equivalent to false here. Next here, equivalent law. P if and only if Q. If and only if Q, it is equivalent to if P then Q and if Q then P. It is the conditional. It is a biconditional. Here, the in between it is come here and it is also equivalent. So these are the laws of logic here. You need to remember this one. Okay, you have to remember this one. So to solve the further questions. Okay, in the next video we'll solve the questions. Okay, if you like the videos, please like the video and subscribe the channel and share to your friends and students also. Thank you.